demonstration, we have 4 hosts in play. We have our management host, which is currently active. This is logged into the control panel of the command and control server and will be used to execute scripts and manage the botnet. We have host A, who has already been infected by the Zeus bot. However, no additional scripts have been run. It's just infected, communicating with the command and control server with the initial configuration file. We have host B, which is not infected by the Zeus bot. However, it is on the same network as host A, and we'll show how it can be moved to or pivoted to using tools on host A. And our fourth and final host is the Linux shell of the actual botnet controller. However, this won't come into play because it's just handling traffic in the background. A quick overview of the control panel itself. The Summaries tab gives a brief overview of what the botnet looks like in current statistics. This control panel is multi-user, so multiple users can log into this with different permissions that the botnet provider can distribute out. However, most of the information will be distributed to potential clients through the means of a custom control panel or through web forms that advertise what bots are currently available, what information is available, and other statistics. However, the botnet provider can give access to this if required. This includes some statistics about the operating systems, the actual bots itself, as well as the scripting interface used to create and run scripts on infected hosts. We'll dive into that some more when we actually look at the advanced tactics. But real quick, I want to talk about the initial functions that Zeus has out of the box. First, we can view the full information about the system, including IP address, operating system, and time zone, as well as take a static screenshot of the host. So here we see a screenshot of host A. See the password and HR documents. This just provides some initial reconnaissance for the botnet provider in many cases, just to see what type of information may be on the desktop, as well as potentially grab a screenshot of any passwords that may be on the screen. However, if we dive into the files, Zeus also has the ability to take screenshots of defined websites. For example, we have the configuration file set to take screenshots whenever a user left clicks on an E-Trade website. So for example, if we open one of these, we can see a screenshot of E-Trade in the immediate area that the user was clicking in. So in an actual scenario, if this was E-Trade, if an investor is frequently placing orders, selecting new companies to place orders with, the botnet provider would be able to see this and have a record of it. They could then index these images, market them on a custom control panel, and sell them to actors and criminals seeking market information. Moving on to some advanced tactics that botnet operators use that aren't present in the default Zeus installation. As I mentioned earlier, host A has already been infected with the Zeus bot, but no scripts have been run. Our first order of business is to establish a more live feed of what's going on in the system, passively without the user knowing. To do this, we're going to download and install a hidden VNC service. We'll first execute our download VNC. This is simply calling the bot command user execute, which tells the infected host or hosts that's targeted at to download and execute the payload at the defined URL. In this case, our ps.vbs script. It's also important to notice the different scopes of bots that can be targeted. Specific bots can be targeted by name. A list of botnets under the botnet controller's domain can be added, as well as botnets in a certain country. This can be used to conduct targeted actions as well as massive scale actions across specific bots or entire bots under the botnet controller's control. So we see that it's sent and executed, so we have a VNC executable on the system now, and now we will use our install type VNC script, which again follows the same pattern, telling the bot to download and execute script hosted on our command and control server. Looking at the scripts real quick, we see it's just a simple VB script calling PowerShell and telling it to download our VNC executable and storing it in the user's temporary directory as vnc.msi. The install script calls msi-exec against our VNC executable, tells it to install quietly with no restart. Again, if we keep an eye on host A, we will not see any screens popping up. We'll configure it to allow loopback connections, not show any controlling interfaces, not flash the wallpaper during a connection, and not require a password for connection. It's important to note that a botnet controller could set a password on the VNC interface, which he could then sell to clients in order for them to actually gain access to the system. The last part of the script removes the start menu folder for the VNC service. We're using VBScript because it's present on every Windows operating system. Its syntax is very simple and it runs quietly in the background without notifying the user. Again, we see nothing here, nothing new in the system tray, nothing new in all programs. However, if we were to check netstat, we see port 5800 and 5900 listening, which are associated with VNC. Now that VNC is listening on host A, if we're on the same local subnet or could access host A directly, we could connect into the type VNC server. However, we're going to assume for this demo that host A is behind some sort of NAT or firewall and can't be accessed directly. To get around this, we'll use Zeus's callback server function. We will issue the bot the command bot backconnect add. We'll forward port 5900 to the host that we're using as our management server over port 3333. This will force the bot on host A to connect back to our listening service on this host. Use the Zeus callback server, set it to listen on IPv4. We'll accept connections from bots on port 3333, and we will accept connections from clients on port 4444. It's important to note that the backconnect server can be used for any port or service that's listening on host A. For example, if host A was hosting an FTP server or a web server, we could forward this port back to our callback server. As we see here, see connection on port 3333, and we're listening on port 4444. We'll connect in with our VNC viewer, point it at our local IP address on port 4444, and connect. As we see, we have a Windows desktop present, which happens to be host A. So now we can see anything that's happening on this host in essentially real time. Any Windows screens that open, anything like that. We can also get even more sneaky and advanced if we want to record the session. To do this, we're going to use VNC to VLC. To do this, we will call our program flvrec. Set our output file. Now, VNC to FLV is an open source program. It's readily available. It runs on Windows and Linux, and it essentially connects into a listening VNC server and will record what's going on. Put it on our desktop. and we'll call it test.ffv. We'll connect into our reverse connection. However, if this host was publicly accessible from our management server, we could directly connect into the VLC service itself, but for this demonstration, we'll just connect into our back connect. We'll see we've started recording. Our passive session is still up, and we can see what's going on. This is particularly useful if the user is storing passwords in plain text. Not only can we see what's happening in real time, but we can also have a record of this now saved in the recording file. Botnet Provider can provide real-time access as well as the historical files to clients based on different pay tiers or based on the information that's present. For example, if this was an HR employee, we see that they have a spreadsheet of different employees, their salary level, their social security number, their address, their bank account number, anything that could be used for identity theft, blackmailing, any number of things this botnet provider could sell to its clients. Furthermore, as I said, we can view anything that's happening on the screen. So for example, if this investment firm utilized E-Trade to conduct their trades, we could view everything that's happening in real time that they're making trades, as well as historical trends. If this botnet provider had a client who is highly interested in market trends, they could download historical videos and view trends that are going on, as well as view real-time trades and make trades almost in real time as the investment firm is doing. If we end our session, our VNC session, and stop our recording, we can navigate to our desktop where we outputted our file and view the raw file of our recording. And we see the session. Now we have a clear record of the passwords that we can go back and historically and see, and we could also do the same for the HR data that we viewed, as well as the real-time trade data. The next step that we want to do is establish another line of persistence. To do this, we're going to add a remote desktop user to the system and allow ourselves to connect into the remote desktop session without the user knowing. To do this, we're going to call another VB script called addUser. This addUser script uses the net user, net local group, and net accounts, and net firewall commands to add a user called default with a password of password to the administrators, remote desktop users, groups, as well as set an unlimited password age and allow remote desktop through the firewall. So we see add user completed, and we'll also enable our shadow script. This allows us to simultaneously connect into Windows remote desktop sessions as well as shadow a user's movements without them seeing, similar to how we were doing in VNC. The script is simply done by modifying 4 registry keys, which are allowing our shadow session. So now we can remotely connect using remote desktop. Again, for the sake of this demo, we're just going to directly connect to host A. However, we could use the backcall server to port forward port 3389, which is associated with remote desktop, and remotely connect to the host that way. But for this demo, we'll just directly connect in. We'll use our newly created default user. And we see here that we are now on host A as with the remote desktop session, and the user that's currently on has not been notified. Using a built-in Windows program called shadow.exe, This allows us to shadow another console session. This can't be done remotely. You have to do this from a remote desktop session, along with the registry edits that we executed in that script. And we'll shadow the current console session. Console. See that the user is not prompted. And we have a similar situation where we can view what the user is doing on their screen. The next action that we're going to show is moving laterally from host A to host B. To do this, we're going to use our lateral movement script. The script calls another VB script that's hosted on our command and control server. Looks something like this. Telling it to download psexec from our command and control server, our add user script and shadow script that we used previously on host A. And we're telling it to copy the scripts from host A to host B and then execute the scripts. By doing this, we will add the default user that we used to connect on host A, and we'll also allow the shadow as we saw on host A. This will all be done in the background without the user being notified. This is typically done in order to expand the amount of information that a botnet operator can sell or gather from a network, while minimizing their chances of being detected or having their malware removed from the network. So if we refresh, see that it ran. Similar to the situation before, if host B was directly accessible by our management server, we'd be able to remotely connect into it using remote desktop. However, we're going to pivot through host A directly. Again, using our default account that we added. We will open another remote desktop session from host A to host B. We will connect with our default user that we just added on host B as well. We see host B down here, and we see that we are on host B. We'll open a command prompt and do a query session. This allows us to see what other sessions are currently open on the host that we're on. In this case, we have the services, the console, which admin is logged in, and our session. So we will take control, or snoop on, rather, the console session just as we did on host A. Again, no user prompt. And we can see everything that is happening on the screen. In this case, it looks like someone is looking at confidential financial information, probably trends of something of that nature, and other financial data. The botnet operator could then sell this access, whether it's by means of copying these files or providing this passive remote access to one of their clients. The other thing that we can do is show how host A can take screenshots of the information on host B and upload it to a server. So if we open our snipping tool, for example, and say host B had their financial trends open. We can open our snipping tool and grab a quick screenshot of this. We'll save this locally on the system. Financial trends. Now we could continue to do this for the entire session. The user on host B has no idea that we're actually looking in on them, so we can continue to take screenshots, but that should suffice for this demo. We'll close our session onto in host B. So we see now we're back on host A, and we have our screenshot sitting on the desktop of the financial data. Now the next step is to upload that to command and control server that can be posted to a web form or a custom control panel. To do this, we can either download the program ourselves in this remote session, we can push a client or program via the bot that we have on host A, along with a number of other things. For this demo, let's push down a file to do it for us. To do this, we will use our script to download PSCP onto host A. Now we could also remotely execute PSCP through this interface by providing command line arguments to the end of this command and point it directly at a PSCP executable. We'll just show the command itself. So we should have a PSCP executable now. I'm going to use C users admin data local temp pscp.exe. We will push up financial trends to our remote host. In this case, we'll just push it right up to our command and control server. Again, this could be scripted and controlled right through the botnet, but for the sake of this demo, we'll just do it manually. And we'll minimize our session. If we go to trends.png, we see that our file is now remotely accessible on our command and control server. This can be moved later on. It can be indexed into another control panel. It can be sold. Any of this information that the botnet controller has, or any of the information that's either on host A or host B at this point, can be exfiltrated and indexed and sold and distributed to the clients of the botnet operator. These sessions are not limited to one at a time, however. For example, we can do a combination of things. So as we see here, we still have our remote desktop session on host A. We'll use that to connect into host B, just as we did before. Execute another shadow console, and we see the financial trends again. We can also go back out and connect to our backcall server. So now we have financial trends on host A, and we see the financial trends on host B and the HR documents on host A. This shows the sheer power that one single infected host can have, and the amount of information that a botnet operator can get and sell just from one infected host. The final demonstration that I want to show is what happens if a botnet operator thinks that his network has been compromised. Either the malware has been removed, or think that someone is onto or monitoring their actions. Since we have a shell on the system and can download scripts, we can execute this erase Windows script. Set it to enable. Again, this is downloading a VB script that's hosted on our command and control server. It's calling PowerShell to download our erase file, create a scheduled task to run as the system user, and execute erase.bat. And then we call it to run erase.bat directly. Erase.bat is a simple batch script that calls the system drive, selects all the files on it, and tells it to delete. Some cases it will shut down, other cases it won't, but the botnet operator can do that remotely. He can always shut down the host remotely. So if we look over here, there's nothing going on with the host. Things are going along fine. For it to take a sneak peek at the command prompt, we see command.exe running his system. That'll do its thing for a while it goes and erases critical Windows files, documents, everything like that, all the good stuff. Eventually, when this finishes, we will be able to it'll either restart the system itself, or we'll be able to restart it manually ourselves after a defined period of time. We see now that our command.exe has stopped. Unfortunately, we inadvertently destroyed our shutdown task while we're at it, but the bot is still running and active, so we can initiate a reboot script. This is a simple built-in command for Zeus called OS Reboot, which forces the operating system to restart. At this point, the system is pretty far gone. There's not going to be too much that saves it. See the system reboot. Shutting down, coming back up. Looks like we had a slight startup problem, so went through the start screen again. And now we're back at the Windows repair page. Definitely not a good sign. All that's left of host A is a sufficiently broken system. There's not going to be any chance of, or any timely recovery of this. There's not going to be any automated recovery of this. It's a fairly broken system. The system restore won't work. It's essentially going to have to require a full reimage of the system. And this is just one avenue of potential attack vectors and tactics that a botnet operator could use to exfiltrate data, break computer systems, and run a black market using a publicly available, well-known botnet to conduct things that it was never originally designed to do. Thank you for your time.